Alright, so this video is on 3-7, and it's going to teach you about slopes of parallel and perpendicular lines and kind of how they apply to geometry. It's a review for kind of some algebra concepts as well. So hopefully when you're done taking notes today, you will be able to compare slope and parallel lines and compare slope and perpendicular lines. So hopefully some terms that you know, if you're comfortable with. Parallel lines, the slopes are the same. That's very important. Slopes are equal. Parallel lines, not a very good artist here, and you know that. There's one, there's another, and to tell you that I want these lines to be parallel, I'm going to do a little arrow. Oh, that's an arrow. I'm going to do an arrow there, and a single arrow there. Perpendicular lines, slopes are negative reciprocals. So what that means is if I have one line with a slope of positive 1/2, the negative reciprocal, I'm abbreviating both, would be the opposite sign. The negative makes it opposite, so this would be negative in this case. The reciprocal means I flip the numerator in the denominator. So it would be negative 2/1, or just a negative 2. Okay, so if two lines are perpendicular, one slope could be positive 1/2, and the other slope would be a negative 2/1, or negative 2. Perpendicular lines, and you're talking about them, perpendicular means that they're 90 degrees to each other. So these lines could be oriented, this picture could be oriented, it could be twisted. But I'd need to make sure I told you that that's 90 degrees. If one of the 4 angles is 90, that means that all 4 are 90. These need to be supplementary when they're side by side, vertical, kind of top and bottom. Okay. Moving on in your notes. Example 1 is just checking for parallel lines. Remember, parallel lines means that they have the same slope. So I just need to check to see if the slopes are the same. Here, if I was going to find the slope of these lines, I would want to make sure I could find 2 points. So here's a point, right, that -2, -4, 1 and 5. So I want to find the slope of that line. I can do it by counting my boxes. So up 1, 2, 3, 4, 5, 6, 7, 8, 9. Over 1, 2, 3. So I would have up 9, over 3, rise over run. That would reduce down to 3. They definitely look parallel, but let's just kind of double check. So I have the point 1, 4, and 3, 3. So we could do the counting again. If I count up, 1, 2, 3, 4, 5, 6, 7. Make sure I'm on the right spot, and then I went over 2. 7/2 does not reduce to 3. And maybe I counted wrong. I want to double check. 1, 2, 3, 4, 5, 6, 7. I definitely did not, right? We could also kind of look at my coefficients. The difference between 1 and 3 would be the 2. That's my change in x. The difference between a -4 and a positive 3 would be a 7, and that would be my y. Remember, rise, change in y over change in x. So if these are not equal, no, they are not parallel. I'm just going to use the parallel symbol. Okay, so take a minute and do your quick check. Okay, so for your quick check, line L3 contains those 2 points, and L4 contains those 2, and they'd like to know if those 2 are parallel, and explain. My explanation can simply be, yes, the slopes are equal, or the slopes are not equal. So let's do A first. So the change in my y's would be 2 minus 1. Change in my x's would be -4 minus 3. And I, of course, could have set this up as 1 minus 2 all over 3 subtract -4. This small one over here, and this will get me the same fraction when I reduce. 2 minus 1 is 1. Negative 4 subtract 3 is a negative 7. So now let's try the line L4. So for L4, I would have, 0, subtract of negative 2, or just plus 2. And then negative 4 subtract 8. Let's reduce that. 2 minus a negative 2, 0 minus a negative 2 would be a 2, right? Those two negatives make a positive. Negative 4 subtract 8 is a negative 12. And I would reduce that to negative 1, 6. So unless I did my math wrong, that's a no. They are not equivalent. Okay? So now they're gonna give us two lines. We're gonna tell them if it's parallel or not. Again, if I'm looking for parallel, that means my slopes are equal. So for for quick check A, I'm just gonna look at my slopes. For this one, it's a negative 1/2. That was easy enough. Over here, I do not have my slope. Okay, this is in standard form. It does not give me my slope right away. You have two options at this point. One option, and I'm not sure how you guys are going to feel about this, is to manipulate this equation so it's in y equals mx plus b, so that it's in slope-intercept form. I'm going to do that first. I'm going to show you a pattern. So if I have 2x minus 4y equals 9, I want the y by itself, so I'm going to subtract 2x from both sides. So on the left, I'm left with a 4y equals negative 2x plus 9. If I had put 9 minus 2x, it would have been the same exact thing, just written differently. I'm going to divide everything by 4, and I mean everything. So I have y equals, I'm going to reduce that to negative 1/2 x. And even though I know my answer already, I'm going to continue, plus 9 over 4. The reason I knew my answer at this step is because in reality, if my question is what line, are they parallel or not, all I need for information is the slope. If I have a negative 1/2 and a negative 1/2, this is a yes. They are parallel. They're parallel because their slopes are the same. Another trick, and we can apply it over here if you want to. Sorry, I kind of overstepped the room there. My slope here is still negative 1/2. Over here, if you notice, we had negative 2 over 4. So that means I took this 2, I changed the sign on it because I moved it across, and I divided it by whatever was in front of y. If you want to, if you have standard form, and you want a quick way to find the slope without manipulating your equation, whoops, that's supposed to be an O. In standard form, your slope is always going to be negative a over b. I should make those capitals. I'm going to do that right now. I made a mistake. Change your notes. A and B. I made them capital just because a capital A is always in front of your x. A capital B is always in front of your y. So here I would grab my A and divide it by my B. My A is 2, and I'm going to make it negative. This is the slope of this line, and I'm using this idea. So m equals negative 2 over 4. If I reduce that, I'll get negative 1/2. So let's see if they're the same. Negative 1/2, negative 1/2, this is a yes. The explain, well, my slopes are the same, and when slopes are the same, they're parallel. Example 3 says, write an equation for a line parallel to this that contains that point. So if they've given me this, all I need from this is the slope. So the slope of my new line will also need to be negative 4. Because my new line needs to be parallel, slopes are the same when there's parallel. And then I've been given this point. They don't specify what type of equation they're looking for, just an equation. So if I've been given a point and a slope, I would choose to do point-slope form, which is y minus y1 equals m times the quantity x minus x1. So I'll keep this always as a y. I need to change the sign on my y coordinate, so that'll be a plus 2. My slope is a negative 4, because it's a parallel line. It needs to be the same as the slope of this line. X minus 1, because I'm always doing the opposite. I could definitely manipulate that and put it into a different form, but they haven't asked for a specific form, so I'm going to keep it like that. Okay, so try your quick check. Pause. Alright, so this is asking the same thing. Remember, this negative x has a coefficient of negative 1. If it's parallel, my new slope will be negative 1. The point that they want it to go through is negative 2, 5. Again, I'm going to use point-slope form. So keep the y. Negative y, negative is another way of saying opposite, so the opposite of 5 is a minus 5, or a negative 5. My slope is a negative 1. Keep that x and x. The opposite of the x point, no matter where you're looking, would be a plus 2. That's my answer. They haven't asked for any other form, so I'm going to keep it just like that. If they had, I could move things around like we did in example 2. Alright, example 4. Checking for perpendicular lines. Perpendicular lines get a little bit more complicated. Remember, perpendicular lines are negative reciprocals. I need to make two changes. I need to take the opposite sign, and I need to flip the numerator and denominator. Alright, so if I'm going to check this picture, I'm going to do 2 points, again, just like we did above in example 1, and make sure that this slope is a negative reciprocal to the other slope. So for here, if I was going to count up, 1, 2, 3, 4, over 1, 2, 3. So rise of 4, run of 3. The next line, I have a point here, and a point way over here, and you could definitely just find the differences in your x and y if counting it on these boxes is kind of rough on your eyes. Maybe I'm just old. Okay, so 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4, 5, 6, 7, 8. So I have a 6 over 8, but let's remember when I did my over, I went in the negative direction. I was going to the left. And if I look at this line, it's going downhill. It's a negative 6 over 8. So let's reduce 6 over 8. I can't reduce 4/3. I have negative 3 over 4. They could both be divided by 2. This is positive, this is negative, right? I'm comparing this slope to this slope. 4/3, if I were to flip it, would be 3/4. So yes, these are perpendicular. Their slopes are negative reciprocals. Okay? So I'm looking at this and wondering where the picture is for L3 and L4. Maybe I'm just not seeing it, but I don't see it. So quick check, you can't do, and I'm very sorry. Alright, moving on for example 5. I want you to write equations of perpendicular lines. So this is a very similar situation. The only thing is, when they're parallel, I can just take my slope of 3 and be done. Now I need to find the negative reciprocal of that number. So negative 3 over 1. So negative reciprocal means I change the sign. For this equation, it's negative. For a line perpendicular to this line, it would need to be positive. Reciprocal means I flip the top and the bottom, so I'm going to have a positive 1/3 for my perpendicular, my new perpendicular line. It still just gives me a point of negative 3, 7. So again, I'm going to use point slope form, sorry. And I'm just writing this out so you have it. I mean, if you know that by now, you're good. Okay, so y, the opposite of my y term, so minus 7, m, x, and the opposite of my x term, which is a plus 3. That's my answer, I'm all set. Quick check, I'm going to do a similar thing. The difference is, this isn't in y equals mx plus b form, so I would mess with this, I would manipulate it to be that. You are not going to be able to do the trick that I showed you for standard form because it's not in standard form. The x term isn't first, and the x term will be a negative. Okay, so if I was going to find a line perpendicular to this, I would take this and I would manipulate it. I would move my x over. I would add x to both sides. So I now have 5y equals x plus 10. I put the x first because in point slope form, it's normally where it shows up. There's a 1 there, and I'm going to divide everything by 5. I'm going to divide everything by 5 because you guys have told me that this is something that bothers you, the kind of manipulating. But in all honesty, if I was just looking, all I really need from this equation is the slope. And at this point I have the slope. The slope of this old line is 1/5. So, for my new perpendicular line, I'm going to take the opposite, so a negative, since that was a positive. I'm going to flip it. I want the reciprocal. I want the negative reciprocal. So 5/1. That's equivalent to just negative 5. They've given me a point that they would like this line to go through. I'm going to use the same formula as above. And I'm picking that formula because I have been given a point and I have been given a slope here. Alright, so keep y, opposite of my y term is a plus 4, not term, excuse me, coordinate. My slope of my new line is a negative 5. And then x minus 15, or x in the opposite of the x coordinate. And again, I can leave it just like that. And all done. Alright, so for your independent work on this, it's going to be page 177, 2 through 24 evens, 25, 29, and 40. Like always, if you have any questions, let me know.